Please don't have your own conversations. And here we go. So for now, no conversations, okay? So there we go. I already worked ahead and I typed in this into L1 and the other one into L2. So every time, guys, there's no guesswork there. X, Y. So L1, L2. Even if it doesn't seem right, you will see down the road that sometimes time will be here. It's still going to be X and Y. Okay? There's going to be, when we do logarithmic functions, time is sometimes your Y variable. So you're like, wait a minute, it's always X. It's always been X. Why is it Y now? It stays the same. It never changes. Yes?
Is X always on the top?
Always. X, Y. So X, Y, or if it's like this, X, Y. Okay? That's just how it goes. I entered everything. I should have checked if this is going to match my equation, because it could be that I made a mistake typing this in. But let's hope for the best here. Explain, graph the data on your calculator, determine the degree of the polynomial that would best fit the data, explain. Okay? For now, Philbert, please. All right. For now, he can just follow here, okay? Anyways, I'm going to go stat. Zoom stat. I turned on my plot 1, and this definitely looks like a cubic, right? A degree of 3, because it's got one turn and another turn. So there's no other way to do this than to pick a cubic. So the degree, what was that? Would be 3. A cubic function would best model, right? Best model this scenario. I know this. I know because the plot shows 2 turns. Okay? The plot shows 2 turns. I just remembered now. Sorry, Nancy. I forgot. But I will unforget. It's like, I will unforget. No, there you go. Run. No time to waste. Okay. The equation now. I will go and do the, perform the regression. 1, 2, alpha, trace, enter. Does a pretty good job. So I'm going to run it again. So here it is. Stat, calc, cubic regression. You write down your equation. Okay? So this would be 0.009 x cubed minus 0.33 x squared plus 3.85 x minus 10.14. And I just made sure the first a was not rounded to 2 decimals. I mean, if you did, it would be 0.01. So if you did that, that would technically also be all right. So I have that. Using the equation, find the maximum predicted depth at a high tide during the day. So between 7 a.m. and 6 p.m. That means that it's between 7 and this would be 18, right? Between an x value of 7 and 18. I will show you another trick here. If you were with me in grade 11, you know this trick. You got to trick the calculator if you want to do vertical lines. So let's say you graph this and you want to see where is 7, where is 18. This is where you have to type in 9 nines like this. And if you want to graph one at 7, you got to go x minus 7. So let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you go x minus 7. If you graph that, you know that this is where 7 starts. Like x equals to 7 is there. And if you want to have one at 18, you do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. X minus 18. So now you know that you only want to stay between those two x values, right? That's the only part that we're considering here. So it says the maximum depth. So we want to look at that. That's the highest point that I have in this stretch here. So second trace maximum. I will find the left and the right. Enter, enter. So that is 4.39, right? I'll write down the whole point. So I'll go second trace max. I'll write down this whole point. And then I'll just say 4.39 meters is the maximum here, right? So basically, if you consider this, okay, it's that one right there that I found, okay? Using the equation, find the lowest predicted depth during the day. So I'm going to go second trace min. And based on this, it's going to be here at the lowest point, right? It doesn't get any lower than that within my daylight time, right? So I'm gonna go find it. You go to the left of it, to the right of it, and there you go. So the lowest is 3.27 at 15.82 hours, right? So I'm going to go 15.82, 3.27. So 3.27 meters is the answer here, okay? It's the lowest point there that I found. Using the equation, find the time or the times where the depth is 3.8 meters. So I will put it into Y4. 3.8, right? 3.8. There seems to be one there, and one here. I'm predicting, based on I'm just going to show you the key here for this one. The first one is, so what we'll do is we'll let Y2, we'll let Y2 equal to 3.8. And then we go second trace intersect. And we'll find the intersection here, here, and here. For this, guys, I would, if you do this, there's a lot going on here. I would turn these two lines off, the vertical. So enter, enter. So you just got to make sure the equal sign is not highlighted. If you press equals, it will only do it will only graph the ones that are highlighted. So that way you can kind of like remove the noise if you need to. So you find that one. So that's 7.03. So technically we are within, right? We're past 7 o'clock, so this one still goes. So I'll go 7.03. I'll find the other one. At 12.74. And the last one, you got to go closer to it, right? The last one is 18.11. Does this one qualify? This is only good between 7 and 18, right? So this one is technically out. This one doesn't qualify. This is past 18, okay? 18 hours. So this is where I want to review, how would you write 7:03 in time, like hours, right? You got to go hours and minutes. So it'd be 7:03. You can't go 03, that'll be wrong. You got to go 0.03 times 60 minutes, right? If you do that, you get 2 minutes rounded. It's 1.8. This is approximately 2 minutes. So you have to go 7:02, right? And 1274 would be 12. You got to go 0.74, like you got to take the decimal, multiply that by 60. You're going to get 44 minutes approximately. So it's 12:44 in the afternoon, right? Past noon. And so these are the times. If you want to get full marks, this is really close, but if it's asking for the time, it's not like how long did it take, it wants the time you need to convert, okay? So convert. Okay. Let's keep going. What's the depth predicted at 1630? What am I going to put second trace value, because they give me the time. X is going to be 16 what? What's 1630 in terms of time? 0.5, right? So in this case, you got to do the opposite. We used to multiply by 60. In this case, you got to go 30 divided by 60, you get 0.5. So you have to convert your minutes to hours. Okay? 16.5 hours. So if you do that, you get 3.31 meters. That's the depth there. What's the depth predicted for 11 p.m.? Is this a valid prediction? 11 p.m. is, you got to add 12 to it. That's 23, right? 23 hours in the 24-hour format. So you go second, trace, a value. X is equal to 23. You're going to get Y is equal to 10.68 meters. And just to give you a bit of, you can't even fit that in your current window. You'd have to change your X max to, let's say, 24, so that you would actually see 23. So you can tell that past the limit that I gave you here, it just keeps on going on indefinitely, right? Technically, our parabola, or not parabola, our cubic function, that's why it's this high. Is this valid? I just wanted you to note that this is not valid. As it is outside the domain and range. Because this is just keeps on going up indefinitely. So it's not realistic because it just keeps on increasing no matter how far you go, right?
Interruption. Christine Gauthier, please go to room 53. Christine Gauthier, 53.
1, 2, 3, 4. 4 and 3 is 7 and 1 is 8. So 8 marks for this page. So put a total out of 8 there, please. And then we'll do the back side. This is not the back side of that one. This is the back side. Has a degree of 3, 2 turns, negative leading coefficient, 3 x-intercepts. So lots of stuff going on. Cubic, 2 turns, negative leading coefficient. So if it has 2 turns, we kind of know what to expect. If it's negative leading coefficient, we expect it to go down from left to right. So we'll do this. Okay, negative leading coefficient, 3 x-intercepts. So we just go like this. You cross it once, you cross it again, and a third time. So that's what I would want to see, and I see it crossing 3 times. So that meets the criteria. So you get 1.5 for this one, and you get 1.5 for this one. It says a parabola, 1 x-intercept, negative leading coefficient, and a y-intercept of 0, -3. So what does this mean? It means that obviously if it's negative, then it's going to do this, 1 x-intercept only. So I'm going to place mine here or here, but it's going to be along the x-axis. So if you go here, I'm going to make a 0, -3 right here, and it's going to keep decreasing from there. Or you could have it on this side, making it through the y-axis there. So this is your 0, -3 there. Okay, so those are basically your only options. Yeah.
Can you give an example for the first 7 one? The 7
This one here?
Yeah. Can you give an example?
An example where this is going to happen?
No, like an equation.
Yeah. Oh, like instead of sketching? Or no, because it says sketch the following.
Oh, okay.
But if it had been given equation, then just write one and I'm fine with that. Yeah. What's that? F? So we've got 8 and 3, that's 11 total. Okay, so put a total out of 11 on this one, put your name and last name on it. So you have to be careful when time is involved.